All right, let's take a look at topic number 7, review solving quadratic equation. So I may have said this before. What's the difference between a linear equation and a quadratic equation? How do I know when I see maybe like 2x plus 1 equal to 4? How do I know when I see this is a linear equation as compared to when I see, x squared plus 2x plus 1 equal to 0? That is a quadratic. How do I know the difference? The steps are different, you know, on how to solve the two. That's why I need to know which equation am I solving. I know the first one is a linear equation because a variable is raised into the first power. Linear equation has a highest exponent of 1. Quadratic equation, the variable has a highest exponent 2. Okay, that's how you know the difference. Later on the semester, we talk about how to solve equations that have that have exponent higher than a 2. Okay, that is actually about a third of what this course is about. Okay, it's actually solving equation that have exponent higher than 2. All right. So remember, linear equation highest exponent is 1. Quadratic equation highest exponent is 2. So how do you distinguish between linear and quadratic equations? We can just write it down. It's fine. Linear equation have exponents 1. Quadratic equation have exponent 2. The highest exponent is 2. You can add the word highest right here if you want to. The highest exponent is also called the degree of the polynomial, but I'm not gonna use all that fancy word to say. You can just say have highest exponent 1 and have highest exponent 2. The first 3 steps on how to solve quadratic equation is the same as the linear equation. Okay, identify your term, excuse me, identify your terms. All right, multiply or distribute, combine like term on each side. So it turns out if you ever took Math 108 or Math 102, there's actually 4 different ways to solve quadratic equation. Okay, we will talk about how to solve quadratic equation by graphing in this class later on. But mainly to do it arithmetically, there are 4 different ways. The first one is called by factoring. So my algorithm here, my steps here are really for solving quadratic equation by factoring, just like the one I did in the previous topic where we find a restriction on the variable. Okay, identify your terms, distribute or multiply, combine like term on each side. Step number 4 is where it's different. Step number 4, quadratic equation, we got to move every term to one side and let the other side equal to 0. Okay, one side of the quadratic equation got to equal to 0. And which side should you move the term? Left side or the right side? Well, that depends on the the square term. We got to make sure the x squared term is positive. So if it's so if you have a negative x squared term, you move it to the opposite side. So that means everybody will follows. Okay. So you move all the term to the side where your x squared term will be positive. Combine like term if you need to, then factor. Okay, we have to factor. Once we factor, we set each factor equal to 0 and solve for the variable. So very similar to what I did in the previous topic. So right now, this particular quadratic equation has 4 terms. And the x squared term on the right hand side is negative. All right. So none of the four terms, has parentheses, so we don't have to do any of those multiplication. So step number four, I can jump to step number four to go ahead and start moving them. So since this is negative, I'm gonna move my negative 4x squared to the left side. So is my negative 3x will come to the left side. All right, go by the exponents. So negative 4x squared moved to the left side becomes positive 4x squared. Negative 3x comes to the left side becomes positive 3x. 12x is still positive 12x. Positive 9 still positive 9 equal to 0. All right. After we move them, we need to combine like terms. These two terms can be combined. So that's 4x squared plus 15x plus 9. All right. So this left side is a trinomial, so I'm going to try to factor this. So 4, I'm going to do this on the side. 4 can be 1 times 4, 2 times 2. Find all the factor of the last term, 9. That's 1 times 9 or 3 times 3. So just by looking at it, I'm probably gonna use 1 and 4 because 2 and 2, 3 and 3, I don't think I can come up with 15 in the middle. So I'm gonna use 1x and 4x, 3 and 3. So my outer is 3. My inner is 12, and that should give me a 15x in the middle. All right, both gotta be positive. And once we factor, then the next step is set each factor contains the variable equal to 0. And solve for x. So I'll move the positive 3 over, so there'll be negative 3. Move the positive 3 over, there'll be 4x equal to negative 3. And divide both sides by 4, so that should give me negative 3 over 4. Right, positive 3 come over, become negative 3, divide both sides by 4. So that's negative 3 over 4. All right, this is very important because this is a very important type of problem because it's telling us that if the exponent is 2, then by simply factor it, we can actually have exponent on the variable become 1. So then we will actually end up solving for linear equation. So when it comes to solving equation that has exponent higher than a 2, it's a similar process. We trying to narrow down, we trying to take whatever the exponent is and knock them all the way down to a quadratic. Because from quadratic, then I can maybe use factoring technique to have exponent to the first power and solve it as a linear. All right, another way to solve quadratic equations by square root property. So here in a minute, while we're gonna solve equations, when taking a square root on both sides, make sure you remember when you take a square root on both sides, the answer will always be positive and negative. All right. The square root property are designed for two terms. And the equation, a quadratic equation only has two terms, just like this one. It's designed for the quadratic equation to have two terms. Okay. So right now my x squared plus a is equal to 0. So since I only got two terms, what I want to do is isolate my x squared term by simply move the positive 8 over. So I should have x squared equal to negative 8. All right. So once a square term is isolated, so this technique only works if I only got two terms. Once it's isolated, then I will take a square root on both sides. So when I take a square root on both sides, square and square root cancels out. I should have an x. When I take a square root on both sides, my answer will always be positive and negative. Okay, got two answers. All right, let's simplify this. Square root of 8, simplifying the radical. Square root of 8. If I break down the 8, that should be 2, 2, 2, right? Take 2, 2 to go outside as 1. The other 2 stays inside your radical. So square root of 8 should be 2 times square root of 2. All right, square root of a negative 1, that's when I should get an I, right? Square root of negative 1 is I. So my answer is actually negative 2 times square root of 2i and positive 2 times square root of 2i. I actually end up with two answers, one positive, one negative. When I take a square root on both sides, make sure you remember the answer should always be positive and negative. Now this problem, technically, this is actually two terms still. This is your x squared term and a negative 40. So I can still use the square root property. So isolate the square term. So I'm going to move the negative 40 over. So that's x plus 1 whole thing squared equal to 40. So you don't have to multiply this out. Since I only got two terms, you can simply take a square root on both sides. So square and square root cancels out. The left side should simply just be x plus 1 equals. When I take a square root on both sides, my answer should be positive and negative, right? Let's simplify square root of 40. I know 40 can be brought down using 2. That give me 20. 2 again give me 10, right? 10 is 2 times 5. So it takes 2 to go outside as 1. So out of the square root of 40, I should have 2 coming out. 1, 2, 1, 5 stays inside the square root. So that should be, so if when they stay inside, they're multiplying. So 2 times 5 give me 10. All right. So to get x by itself, now I will move my positive 1 over to the other side. So that positive 1 move over, I'm going to put right in front of the plus and minus sign. So that will be x equal to negative 1 plus and minus 2 times square root of 10. All right, that's two answers, okay? This is two answers. Negative 1 plus 2 times square root of 10 and negative 1 minus 2 times square root of 10. This problem is tricky. It looked like there are four terms, but no. The negative 2 on the left side and the negative 2 on the right side. Okay, so whenever you have exactly the same term, same sign, same everything on both sides of the equal sign, they automatically cancels out. So technically, this equation, this quadratic equation, only consists of two terms. All right, but I want my square term to be positive, so I'm gonna swap them. Okay, I'm gonna move this guy over here. All right, but this is tricky. So should I use? Oh, okay, should I use square root property? Should I take a square root on both sides? Should I do it where this is 12a squared equal to negative 5a and take a square root on both sides? No, I actually don't want to do that, even though this is only two terms. Square root property, I don't think it will apply here because it's extra variable. You see, when I use the square root property, what's on the other side of the equal sign is actually a numerical value. Okay, that have no variable in them. So the easiest way to do this problem is actually simply move the negative 12a squared over to have positive 12a squared, positive 5a on the same side, because this problem can actually be done by factoring. So between these two terms, this is not a trinomial, this is just two terms. And the greatest common factor between the two terms is letter A. So I can actually factor out an A that will leave me with 12a plus 5. So I'm linear now, right? A to the first, A to the first. So normally after we factor, we set each factor that contains the variable equal to 0. So this A I factored out got to be set equal to 0. So one of your answer is 0. The other one set equal to 0. Move the positive 5 over, divide both sides by 12. So the other A is negative 5 over 12. Okay, two answers still. All right, quadratic formula. Solving quadratic equation by quadratic formula. The reason why we're using quadratic formula because these type of problem cannot be factored. All right. So there's this thing called the quadratic formula, which is actually derived from this way. Let me go back up. This thing called completing the squares. If I will complete the squares on the quadratic equation form, if we complete the squares of the quadratic equation form, ax squared plus bx plus c, sorry about that, we can derive this formula. So, maybe you might sing it before how to actually solve quadratic equation using completing the squares. But basically, this can be derived, using the technique of completing squares. It can actually result into a formula because it's the same process every time. Okay, because the process is the same, then a type of formula can actually be, driven. So what the A, B, and C inside the formula are simply the coefficient of your quadratic equation. So A is always belong to the x squared term, B belong to the x to the first power, and the C is your constant term. So let's give a try. Let's write down our coefficient and we're gonna plug into the formula. So my coefficient A is 5. My coefficient B, this is actually -1. All right, C is positive 3. So x equals negative b. This negative sign gotta be there, okay? So that would be negative b. B is -1 for me, right? Plus minus square root of my b whole thing squared minus 4 times my a times the c. All right, then remember this plus and minus on the numerator means the numerator has two terms. Both of these terms on the numerator is going to be shared by one denominator, 2 times my a. 2 times the 5. So let me simplify. The -1 times -1 in front of the plus or minus will be positive 1. 2 times 5 down here will be a 10. So now the question is, what is inside the square roots? So all I'm going to do is to type this into the calculator. Okay, just like that, typing into the calculator. That's why I purposely put the -1 in the parentheses. So if we type in -1 whole thing squared in the calculator, -4 times 5 times 3 in the parentheses. If you're typing exactly what I wrote, 4 times a times c, it should be -59. All right, 59 cannot be simplified. It's a prime number. Square root of that -1 is an I. So I can actually say my answer is 1 plus minus square root of 59 I over 10. All right, so this is written in the a plus bi form. Okay, complex number, a plus bi form. And it's always a good idea. The x squared term is positive when we use quadratic formula. Okay, so I'm going to take these three terms to the right side. So this come over become positive 2x squared. Positive 5x come over become negative. Negative 8 come over become positive. It's always a good idea. You're making a lot, you won't making that many mistake on the signs if the first term is, if your square term is positive. I'm going to write down my coefficient now, right? 2b should be negative 5. C should be positive 8. All right, I'm going to substitute into the formula. All right, negative b. I think the formula says negative b, right? Negative, sign got to be there. My b is negative 5 plus minus square root of my b whole thing squared minus 4 times my a is 2, my c is 8, and both of these terms on top divided by 2 times my a, which is 2. So substitute into the formula. All right, we're going to put all this inside the square root into the calculator and see what that is. But on the outside, negative 1 times negative 5 is positive 5, plus minus 2 times 2 down here is 4. So let's see what the calculator give me here. Negative 5 whole thing squared minus 4 times the a times the c, which is 8. We should get negative 39. All right, 39 technically is 3 times 13, which is you only get 1 3 and 1 13. So nobody can actually come outside your square root. So we don't have to simplify that. But the square root of the negative 1 becomes an I. So my answer should be 5 plus minus square root of 39 I whole thing over 4. Okay. All right. So there's three ways on how to solve quadratic equations. Quadratic formula, square completing square root property, and the first one I show was factoring. Okay, factoring should always be our first resort. Try to factor. If not, we will use the other two methods. All right, how do you distinguish between linear equation and a quadratic equation? So just you can just enter what we wrote down at the beginning of this video. Number two, we done this problem earlier. Which technique is best suited for solving this quadratic equation? All right, so we actually did it. I actually showed to you earlier. Question number 3. All right, so see the x squared term is negative. So step number 1, move all the term to the right side. So the x squared term would be positive. So move these two to the right side. Okay, everybody gonna be on the right. Then I need you to factor, okay, using the trial and error method. So this is on the computer portion. So factor, and don't forget to write equal to 0. Without equal to 0, this is not a quadratic equation. Okay, so use the technique that we factor trinomial for the right side and make sure you say 0 equal. I want the 0 to be on the left side. All right, and set each factor equal to 0 and solve for x and enter the answer for x inside the box below. You can just put x equals something comma something. That'll be okay. Number 4. All right, consider the following quadratic equation and matching the standard form. Okay, So for number one, you write down the coefficient A. Number two, you write down coefficient B. And number three, you write down the coefficient C. Okay, that's all you need to do for number four. I'm not asking you to actually write it as a using quadratic formula. I just want you to match up the coefficients. So because I find a lot of times students make mistakes on the quadratic formula because the coefficient student write out is incorrect. So I want to make sure you're able to write out these coefficients. And don't worry, we will do quadratic formula again later on the semester. All right. All right, that's all the question I have on the homework.